So hello everyone, in this video we will solve another LeetCode question, that is palindrome partitioning. So we are given a string S and we need to partition S such that every substring of that partition is a palindrome, and we need to return all possible palindrome partition of S. So let us see this first example. So they are given this string AAB. So first possible partition is A and B all separated, and where each A and B is palindrome in itself, and the other possible partition can be A together and B together, B alone, sorry. So A is palindrome and B is also palindrome, so this is also one valid partition. So since there are only two possible partition for this string, so we have written this output. And let us see this first example and how we can derive these possible partitions. Before moving on to that, you can see that the size of a string can be as max as 16. So we can do something like recursion in order to generate all the possible answers. So let us see this first example and try to derive solution out of it. So this is the first example that they have given, and let me index them on 0, 1 and 2. So first, when we are standing at, let's say we have three possible scenarios initially. What are all these three possible scenarios? Either I can make partition at 0, I can make partition at 1, or I can make partition at index 2. So when I make partition at index 0, my string would look like this. When I make partition at index 1, my string would look like this. When I make partition at index 2, my string would look like this. Now, when I made partition, I also want to make sure that the partition that I made, so that string is palindrome. So I will check if A a palindrome. Yes, A is a palindrome. So I can make further partitions. Now I'll check if A is palindrome. Yes, A is palindrome. So I can make further partition. Now I'll check, is AAB a palindrome? No, it is not a palindrome. So I can't make further partitions. So again, in this first scenario, when I made partition at 0, I have two choices. I can make partition at 1 or partition at index 2. So when I made partition at index 1, so what is that scenario? The before partition would remain same. So when I made partition at index 1, it would look something like this. So again, is this A a palindrome? Yes, it is a palindrome. So I can make further partition. Now I have another scenario, that is I can make partition at index 2. So it is not a palindrome, AB is not a palindrome, so I can't make further partitions. So again, here I have one more case, that I can make partition at index 2. So all the partitions before will remain same, and I made partition at index 2. So is B a palindrome? Yes, B is a palindrome, and we also reached the end of the string. So that means we have successfully created the partition, and this is one possible partition. So we will store this in our answer. So one possible partition can be A, B. So this is one possible partition. Now let's see this scenario. I have only one option here, not two. I have one option. That means like I can make partition at index 2. So when I make partition at index 2, it would look something like this. Now I need to check if this B is a palindrome or not. So yes, B is a palindrome, and we also reach the end of this string. So that means this is one also possible partition. So we will store this in our answer. AA, B. So when you see the output also is same as what we have generated. So that means our approach is correct. Now we need to analyze how we are doing it. So one thing is for sure, that when we are backtracking from here, when we see all the scenarios for 0, when we made partition at 0, and when we go to this one, when we are willing to make partition at 1, we need to remove this partition at 0. That is what backtracking is. So whenever we are doing a backtracking, we need to remove this partition at 0. Similarly, whenever we are backtracking for 1, we need to remove partition for 1, and then we will make partition for 2. So this is one thing we need to keep in mind, and let us analyze with the code how we can approach this question. So this is the same way that we will in which we will write the code, but let us see how we can do it. So let me write this same example, and let's say f is the function that help us to do the backtrack. S is the string and I is currently where we are standing. So I am currently standing at here. So I is, that is what it is depicting, my starting position. Now initially what we have said, we need to check all possible scenarios. So what are all possible scenarios? So from 0, or in more clear way, I need to maintain one IND index which will go from I to n minus 1. Now obviously I will be 0 initially, so I will have 3 possible scenarios. It will go from 0 to 2. So this is what IND is depicting, whether I want to make partition at 1, I want to make partition at 2, or I want to make partition at 0. So this IND depicts where I want to make the partition. So this is what IND is depicting, and this is what I is depicting, where we are currently standing at. So let's say we made its partition at some position IND. Now we need to check, before pushing that possible string into our answer, we need to check whether that string is palindrome or not. So for that we will use we will define a self function, we will define a function by ourselves which will check if a particular string is palindrome or not. So this is what this function will do. So what will be the parameters? This string, this starting position, obviously it will be I, and where we made this partition, at what index we made the partition. So this is the this will be the starting position and this will be the end position, because obviously let's say we are currently standing at I, this is my I, and we made partition at B. So obviously we need to check this entire string for palindrome. So our starting position will be I and my ending position will be IND. So this will denote the starting position and this will denote the ending position. So if this is palindrome, we need to push that particular substring into my answer. So push back. Now what will be that substring? Obviously it will be a substring of S, but what substring it will be? Now before moving on to that, we must make sure that how this substring function works. So this substring function, what it does is, it takes 2 parameters. One is the starting position from where we need our string, and the length of the string till what we want our substring. For example, if we want to take AB as a substring from our entire string S, so let me name this index. So my starting position will be 1 and my length will be 2, because from starting from 1 I want to make a substring of length 2 from this index, from this string S. So starting from 1, length 2, I will take this substring. So this is how substring function works. So in this case, what will be a substring? So let us again draw it. So let's say again I am standing at I, and let's say I made partition at this position IND. So one thing is for sure, that my starting position will be I, that I already told before, but what will be this length? Now if you see from here, when I made partition here, the length is 2. Now how we can write 2 in terms of this IND and in terms of I? So let me redraw it with the help of indexing. So this is A, B, this is 0th index, this is first index, this is second index. This is where my I is and this is where my IND is. So I need to take this much substring. So starting will be I obviously, but how I can derive 2 with the help of this IND and I? So let us see now. So IND is equal to 1, I is equal to 0. So what we can do is, we can write one formula which will give us the length in terms of IND and I. So we can write as IND minus I plus 1. So IND is 1, 1 minus 0 is 0, 1 minus 0 is 1, plus 1, that will give us 2 as our length. So starting from I, index minus I plus 1 length I want to take as my substring. So that is 2. So starting from 0, length 2 I want to take as my substring. So AA is my substring. So here in the length, what we will write? Index minus I plus 1. Then we will again call the solve function, but here we will make index plus 1 as the starting position, because let's see, we have made partition till here. So my next position of I will be here only, because this much length is already been covered. So my next position, my next starting position of I will be here. So index plus 1. But one thing we need to make sure that while backtracking, we need to pop back whatever we have made the partition. So for the further calls, we don't have this scenario. So that's why we are popping it back for the backtracking. So this will keep on happening, and let us understand in more deeper way in the code now. So we will first declare our main answer, vector of string, which will contain all the possible partitions, and we will also create one vector of string res, which will store the current partition. Now we will write one solve function which will help us do the backtracking, and after backtracking we will return this answer. So in the solve function, we will first pass s as our parameter, then I as our parameter. Obviously I will start from 0, so I am directly starting with 0, and then res and our answer. So let us write this solve function. It will be a void, and we need to pass on the parameters now. So string of s comma I and vector of string res and vector of string ans. So base case. So what was the base case? If we reach the end of the string. So if our I is greater than equal to s dot size, that means we reached the end of the string and we made all the possible partitions. So we need to push that possible partition into our main answer. So we'll push back res, which is our current partition, and then we will return. Now what we have seen, we need to loop ind from I till n minus 1. So ind less than n, ind plus plus. This ind is denoting where I need to make the partition. Okay? So when we made partition, what is the first thing that we want to make sure? Obviously if it is a palindrome, then only we will make partition, otherwise we will not. So we'll first check if it is palindrome or not. So we will write one function which will check if it is a palindrome or not. Now if it is a palindrome, that means we want to push that particular substring into our answer. Now what is that substring? We have already discussed. It will be starting from I, then it will be index minus I plus 1. Then we will call the solve function again for further process. So it will be s comma index plus 1 comma rest all things remain same, and when backtracking we need to pop that previous partition that we made. So pop back. Now in the palindrome function, we will give one parameter of s, our starting position and our ending partition position. So we have also seen how we are getting this I and ind. So let us write this palindrome function is palin. So it will be a bool function which will tell if it is a palindrome or not. So it is the starting and it is the end. So what we need to do while start is, so I don't need to explain how we check the palindrome or not. So it is very simple. So we need to just check if our s of start is not equal to s of end, that means it is not a palindrome, so we will return false. Otherwise we'll keep on iterating and keep on moving our pointers, and in the end if we completed the entire string we will return true, because it is one possible palindromic substring. So this is how we write the code. Let us see again what we are doing. So I have declared one answer, one res, vector which will store the current partition, and it will store all the possible partition. Then we are writing a solve function for backtracking, and in that solve function first we write the base condition. After making all the possible partitions, where if we reach the end of the string, that means all the possible partitions that we made till now for that string are valid, are palindromic, so we need to push our current partition into our answer, and then we will return. Now we need to check each and every possible case, like for each and every index we can make a partition or we can't make a partition. So we will run a loop from I till n-1. So if that particular substring is a palindrome, that means we can make a partition, like if we made a partition there, and if it is a palindrome, that means we need to push back into our result, and then we need to make further calls. Now before backtracking we need to remove that partition, so for further processing of the recursion calls. Now for checking the palindrome, we have write this function. It is a very basic, simple, straightforward palindromic checking function. So this is how we do this question. Let us run if this works on sample test case or not. So it is giving us the error. So we haven't defined n, it would be s.size. Let us try it again. So yeah, it works fine on sample test case. Let us try to submit it. So yeah, our code got accepted. Hope you learned from this video. Thank you.